All right. Okay. There we go. Welcome. Good morning. Saturday. Let's check on a few things here. Running. If there, okay. So yes, welcome first of all. Thanks to anyone who's watching. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream around this time each week, working on some stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more at the main website, circuitpython.org, right here. It is basically a version of Python that runs on tiny computers called microcontrollers. You plug it into your computer, usually with a USB cable, shows up like a thumb drive. You can edit a code file on there, and then when you save it, it will execute the Python code inside the little chip on these devices. Today and the last couple of streams, we have been over in Blinka land, which in the way that we're using it, whoops, wrong thing there. In the way that I'm using it, is Blinka is a compatibility layer for CircuitPython. It makes it so you can run code that looks like it was written for those microcontrollers back here, but instead you can run it on a Raspberry Pi or a single board computer or other larger computer inside of quote-unquote normal Python, inside of CPython, which is normal Python. And in particular, we have been working on Blinka DisplayIO, which is the DisplayIO layer. So for microcontrollers like the PyPortal, they have a display on there. One of the ways that you can put graphics on the display is with the core module DisplayIO. So Blinka DisplayIO is that version for that core module, I should say, for Blinka. And that is what I've been working on the last couple of weeks. If you are also new and you don't know, all of this stuff that we're working on kind of is more or less brought to you by Adafruit. If you want to help support CircuitPython and Blinka, the compatibility layer, and all of the great guides and content that come out of it, one of the easiest ways you can do that is just purchase hardware from Adafruit at their website, adafruit.com. They make the microcontrollers. They make all sorts of things that you can plug in and connect up to your microcontrollers. Do all sorts of fun projects and things with, like the PyPortal I mentioned before with the display. That's an Adafruit device. You can buy that on their website. They have Raspberry Pis and stuff as well, although those, of course, are not designed and manufactured by them like the PyPortal. Those are made by Raspberry Pi. So thanks to them, they make CircuitPython and all the development around all of that stuff possible by paying the people like myself who work on it. So huge thanks to them, and huge thanks to everyone who supports them by purchasing hardware. Or even just hanging out in the Discord, sharing, going to show and tell. Lots of ways to support, even beyond buying hardware. Someone who's around. So Blinka DisplayIO, I've been working on adding Bitmaptools to this. Loaded thing. Open up the Good morning, C. Grover. Okay, so last week, I think where we left off was I had figured out what dither does on the microcontroller, which is kind of the first step to making it, to implementing it in Blinka DisplayIO. We got a version implemented here. I think ChatGPT GPT helped us with the bulk of this, and it either doesn't run or doesn't do what it's supposed to do. And I think we were in the process of fixing that. Don't recall for certain. We could always go back and watch the tail end of the video to refresh mind if I need to. But I will start with just checking like what happens here. So if I go and run our test code, I made this thing this week. This is totally unrelated. Oh, it's gonna work. There it goes. Oh. I broke it somehow. That's saved. Oh, you know what it is? It's the color count, actually. You're not allowed to have a color that big. Oh, I'm making some triangle fractals. Using Bitmaptools, I think, right? Some of it. Or just placing pixels. No, just placing pixels. Okay. Anyway, that is unrelated. Bitmaptools. Something else that I was tinkering with this week. The real test here, oh, okay, we are running dither. Yeah, so let's see. Does that crash or run? It crashes. String indices must be integers, not strings. Okay. So probably, oh, okay, yeah, I remember this. So this thing is expecting a, algorithm info is like a dictionary, which I might have failed to, very unfortunate. Failed to copy that. Because basically this is what, these are the constants that we want to be able to pass for this. But the way the function was written, it actually made those a dictionary. And I guess it would have included the example of the two different ones, but it doesn't look like it's here. I don't have, well, we could find it in the stream maybe, but I can't copy paste it out of there. Realistically, it should exist in here. Yeah, okay. The one thing though is I'm not sure. Wait, this is a star structure. So it's a, this a dictionary? Or if that's right for of Python. Okay. Well, we can always do something like back to, I should have copied those out last. And these have the right names, right? Algorithm Atkinson, Flowing Star. Yeah, okay. So can you please convert these C, are they structures? I don't know. C variables to Python dictionaries for use with provided Python function. Give it, I always get confused here between these code box and the, let's copy this. I function be able to do here. Really all we need is to map those dictionaries now to our constants. Have the right values with the right keys. Enter and up arrow, that's it. Terms. Oh, I see, okay. I wish those were just together. So I'll double check these numbers in a minute as well. Should we put those on here? I don't know that it matters where we put them. It's kind of a, whoops, kind of a internal consideration where the actual dictionary mapping is. Like in CircuitPython rather, I don't think it's on this object, but it's only accessed from shared module. So in CircuitPython, it kind of like doesn't really per se. Python like. So let's double check that these match the C code. It's the old catbot there sometimes likes to make stuff up. We had Atkinson is 256 over 8. Oh, okay, my brain was interpreting this as like a key and then another value. It's actually just a list, I guess, or it's probably a set, I suppose, maybe. So we had 256 over 8 would make a float. I don't know if that matters. This would make a int. I mean, it's going to divide evenly anyway, so it doesn't really matter. 256 over 8, negative 1, 1, 258, 0, 1, 2. Okay, and then 3, 1, 7 times 256 over 6. That's a bit more crazy. 7 times 256. Yeah, so that's okay. Yeah. Again, we have floor division versus non-floor division, which might actually matter in this case. I don't know. Is that going to be divisible by 16? Sure. We'll see if floats end up mattering. Maybe we can wrap that, or maybe we can do a float. I mean, we're trying to get to pixels ultimately, which don't have floats, so I think it gets truncated somewhere. Negative 1, 1, 3 times 256 over 16. Yep. 0, 1, 5 times 256 over 16. 1, 1. Yeah. Okay. Fine. And then basically what we're going to do is this will be, is it actually called algorithm info? In shared bindings, though, I care about more so because this is the API. Either it is called just algorithm. Say algorithm. It's going to default. Does it have a default? Defaults to Atkinson. Say, no, we need algorithm Atkinson. And then we can do something like if we could make a dictionary, we could make an actual dictionary out of it, but we only have 2. Kind of inclined to do an if statement. Algorithm app. What? What is that? That suggestion? And then we should be able to just say like algorithm info, which is what this was written for originally. Get that by dither algorithm app. Algorithm passed as the parameter. And then I guess the code must already be passing the constant. Yes, okay, very good. So that should get us past the first thing that went wrong. Bitmap has no object shape attribute. That's probably trying to get the size. Um, get the size. Yeah, just trying to get the width, I'm pretty sure. Wait, this is kind of crazy. I don't know if we need to do all this. Fill row. It must have got this from the C implementation. We need that. So a lot of this looks like it's dealing with different. Well, maybe I mean, anyway. Maybe just width should be fine there. Okay. Shouldn't we be able to fit 0 to 1 minus this? Or no, because sine? Sine? Can't really have negative in the pixel values, I don't think, right? Integer scalar values. Okay, I think we correct that. Well, I don't know. 8. This needs to like right pixels bitmap y. What is out though? Out would be the color in data. Okay, it's a list of true, false, and then but what? How does it know what to write? Hmm. This using this data, or is this a different data? I thought this was like access, essentially the thing on bitmap called data. This is also getting this thing. Oh, here's where that's used actually. Okay, yeah, this is a different thing, I think. Okay, so that's getting it off of there. Huh. I don't know. Doing all the way. This. I don't. I mean, it's so far. Writes a row pixels data. Is dither always grayscale? Dither might be always grayscale. Yeah, I think I'm getting confused in with thing. Okay. So that makes a bit more sense. If it doesn't do color, it doesn't have to worry about that as much. I guess you could technically do color the same way. Essentially, it's got a big pointer to a list of booleans, and in the case of 1-bit, it treats those as 1 pixel, and it writes 32 of them at once. But then in the case of grayscale 16-bit, it's going to treat 16 booleans as 1 pixel. Oh, not really working for 16-bit the way I was thinking either. I mean, it works, but it's still just 2 colors. It's not doing grays. It's not actually grayscale. Seemingly. There's a difference of writing 1 versus writing 5, whatever. Okay. Yeah. So that definitely seems not at all to match what the what this thinks the C one does, at least. Um we need like technically there's no have kind of access. Oh yeah, private one. So then loop over X. We already have Y, so go bit. Wait, didn't that buffer? I don't know, it's kind of weird that code doesn't support anything but 1 and 16. Guess we'll just do but we also need to check data. They're calling out. That's true, do that, else put it to false. I mean 0. Okay. Not crash. Did draw something. Remember what the code is. Thought we were Blinka, yeah. Definitely not that, but what's Phil doing? Well, Phil Row, it says greater than. I mean, first of all, shouldn't it be height? But also, was from crashed last time. Oh. Overflow encountered in scalar multi. Bitmap with the supplied. Oh. Fill row supposed. So this takes a bitmap and a row. And it says if row is greater than width. Okay, so first of all, I feel like that should be height. Let's start there. So in this one, yeah, this is like way different stuff. Okay, I think it just did not copy these very well. So this says bitmap, it says swap, it says luminance data, which seems kind of important. Has Y, and then it has MX. I don't know what MX would be. So let's see. Yeah, totally that's height. That's returning nothing. In fact, this whole thing is void. So I think this is just no. I wish that Twitch would make a thing that tells when comments are like clearly just a bot trying to sell viewers or whatever, and just like kind of auto. That's I guess how you get correctly. So this is going rows, rows, so it's kind of getting rows, and then it's going left to right pass, and then eventually it right pixels. But it also does fill row again here. Could potentially break. Here, I guess. Right to left. Letting rows data. Shifting again. It's manipulating rows data more. But like nothing is writing this, right? This is just generating data and returning it. But nothing is putting that in the bitmap. And also that doesn't really match the C function. I think maybe this one was a bit beyond. One might have been a bit beyond the capabilities of the free ChatGPT, at least last week. Yeah, because like here, fill row, this is gonna like have an effect. Not not getting a response. We might even just be better off having it try to write a Python dither function or find one. Like I gave it the C function and asked it to re-implement it in Python, but there's so much cycling cycle the rows by shuffling pointers. It's kind of a lot of tricky stuff going on, and it seems to have misunderstood, or at least like gone a different direction compared to how this is working. Because here, fill row, it takes all these extra things for one thing, which the Python code just doesn't have. It returns, but only as a means to like exit early. Zero padding out area, zero out padding the area. So I is less than mx. Start on 0, we go to mx, or 1 less. Luminance data, negative mx plus I equals, that is thing, okay. I wish this had a better name than mx. Max? Is it max? Maybe it's max. Probably max. But if it was 10, let's say, starting at 0, we're going to 9, essentially. So negative, so we're going from the end. Well, but we're in C code. Does that work? Can you go from the end? I don't know if that works. So negative 10 plus I, first round through, that would be 0. The luminance data negative 10 equals 0. Can you do negative array assignments in C? Uh, I have no idea what the purpose of this could be, nor does it even. I mean, would this not be the negative of this? And then I would be 0 the first time. Then we have what this thing says is undefined behavior. That's what we're doing. I'm not sure. Follow the use exactly though. So essentially 10, I mean, it is going backwards, I think, right? So that would be minus 10 the first, well, minus 10 should be out of, oh, I don't really know what luminance data is going to be, it turns out. Hmm. Give it this constants class and then signature in the beginning of this stuff. And then ask it to implement its own version of Atkinson Floyd Steinberg did. And not give it the C code so that it won't be the way that works. It's better. Does seem to think it does something with color. I don't think we should be modifying source. Yeah, we should definitely not be modifying source. Maybe that's part of the problem. Maybe it doesn't understand. Don't modify. Only modify function best. some stuff it's not useful. But let's see. Kinda. Certainly be worse. It's not right, but it is arguably a dithered version of Blinka. Um, let's tell it that we're not working at all with colors. Or that we're not, that we don't want to write colors. We only want to write, I guess, grayscale. Well, I mean, realistically, we only want to write black and white, which is pretty much what the C function seems to be doing as well. Because it was writing either 1 or 0, or it was writing 65535 or 0. Move any blank colors. I'm tempted to just tell it to write 1 or 0, and then we could modify it after that. Technically, that's RGB, which means that it would be the 16-bit one. Does it not have the ability to do grayscale? Well, I mean, we ran it on Blinka on the PyPortal, and it did not grayscale. Only convert the image into a 2-level output image. Move any handling of colors in the dest bitmap. Should always end up painting only colors black and white. Um, so that should, like the description, what I described there should be what we want. If the code is what. No. I mean, it's closer, but basically this is just the blue one, and it's now white instead of blue. I've passed in Floyd Steinberg. I'll go back to the PyPortal in a minute. Double check, but I'm pretty certain not what it looked. How's it going, Tithe? Nice to see you, my friend. I think I could try the other one. Right, what is spelled? ish, maybe. Okay, yeah, let me test it again on the Pi portal. I thought we were getting more pixels in the middle Pi portal. Sure, Pi portal we ran it. Seems like. Ooh. Sure, what's going on here? I guess ultimately it doesn't matter because we're not using source bitmap 2. Okay. Yeah. So my Blinka on the Pi portal has a lot more black pixels. So we can try this one. I mean, that looks different than Floyd Steinberg, but still ultimately a lot more pixels. It's rough. I might be willing to just tap out on Dither and submit the rest of Bitmaptools. Hope that someone smarter than me. This is using all the values. MX, count, terms, and then terms dx, dy, terms dl. Things come from. I mean, we could check the order. Maybe these are in the wrong order. Actually, you know, one thing it doesn't seem to use is DL, but not of term. Lots of MX. Count. Terms. There's a terms DL. Okay, there is a DL. X, count, term. Yeah, that version's using everything. But this one... Was that the last one? Well, just removed. It just removed those? Yeah, it just removed them. Okay. I'm curious. Let's try to see if Claude does any better. Well, let's check the order of these first. Maybe if these constants are in the wrong order. Well, I mean, it's not using all of them. But it's definitely seems unlikely to do the same thing as the C implementation, not using all the constants, including MX, which seems to be used a lot in the C version. So maybe that's related to its way of packing data or whatever, but I get the sense that let's give it the C implementations and the start of the Python implementation. See if it can figure it out from. Oh, I forgot to put the Python one. And it just like did it anyway. That's like a one part of my problem with this is like I clearly gave it instructions that it can't actually follow, but it's like, yep, here you go. You stop? Is there like a stop? I almost want to just like go back and make a whole new one again because I don't want it to like use any of the context that it just wrote for itself. Copied the prompt though, huh? That back actually has history here. It might. Yeah, like in that case, like I think it should have been like, yo, you didn't give me the Python start that you said you would, and it shouldn't just like try to write its own. If it's on its own. It did make a fill row. It has all the right stuff on this, which is good. It is checking height, which is also good. Has data for this, which is good. It's not returning anything from fill row. We might be doing better here. We can get rid of dest dirty. We don't need that. Maybe one more thing I should have told it was how to write pixels. Did it write pixels correctly? Yes, no. Yeah, so it did set pixel, which we don't really want. Okay, yeah, let me see. Bits per value. Sure if that exists, but we can work on that in a minute. Okay. Instead of get pixel and set pixel. Okay. I guess I did. Did I do it out of order? I did the last one first, and then that confused it. Maybe. Instead of get pixel and set pixel, please use bitmap. Why? Get set map x. Interesting. This has a copy button before it's done rendering. Will you get the whole thing, or? That looks good. Swap, it seems. Maybe it's called swap bytes and not swap. Oh, there's actually bytes and swap RB. So fill initial rows. What is that? Swaps. Starts at 0. Swap RB. In like some kind of mask thing. Like it just that part though. Okay. Maybe it didn't do it because we didn't give it these. Truthfully, it looks kind of close enough that we should be able to use it less, right? Like, this is different. Or different. Figure out those constants. That should be these. Wait a minute. This says if color space is RGB 565 swapped or BGR 565 swapped, then do this bit. And then it goes if it is BGR 565 non-swapped or it's BGR 565 swapped. We already checked for here, right? Yeah. Okay. RGB 565 swapped. BGR 565 swapped. BR 565. This one's using the swap RB? BR 565 swap. Map has no bits per value. All right, okay. That one was just that. That is another function. You can edit that in this. Ooh, that looks pretty darn close. That actually looks pretty darn close. So this is on Atkinson currently. And I think it's on Floyd Steinberg. Yeah. I will say it is not 100% the exact same, but it's pretty darn close, and I'm gonna call it close enough for my first purposes here. Floyd Steinberg, let's try this one. So this one, to my eye, I don't know. I guess they both kind of excel at different things. The Atkinson one does the dark spots. It makes it really apparent that kind of the top part of Blinka is darker than the bottom part of Blinka, and like this is the original thing. Got the darker purple and the lighter underbelly. Atkinson does that a bit better, but in my eye, Floyd Steinberg does a bit better at basically conveying the actual original colors in a way. Like the Atkinson almost makes it look like the original was not very colorful because it's only sort of accentuating the darks and the lights. And then Floyd, the sort of like brightness comes through as the grayness level, how many pixels there are. I don't know the right way to. Stenberg. I've been calling it Steinberg again. Shoot. That was a thing from last week. Stenberg. Oh, that one's way different though. Uh-oh. I mean, I don't hate it. Pretty good, truthfully, but one thing that it's a bit better at is kind of the vertical lines here than the one on the Pi portal. I really wish they were the same. But I also don't know enough about the actual algorithm. And I kind of want to get this wrapped up, if I'm honest. I would like to get it PR'd and into Blinka DisplayIO if we can. Even if we have to leave out Dither altogether, I'd be willing to try to get the rest in because I want to use some of the other ones. So here we're not using swap. That could be one problem. Does the C implementation use swap? It does. Built-in swap. Okay, so one thing is we don't actually have built-in swap. So we asked it to do something and then I didn't give it the code to actually do place that calls that function. Yeah. I kind of think this almost like broke up the idea of swap into swap bytes and swap RB. And this one is kind of doing the same thing, but combining it together into bitmath. Right, so that seems fine. The built-in swap 16 I wonder about. So this is, I mean, it seems okay, right? It's kind of shifting off the front 8 and putting them around back. I think that sounds fairly standard. That's the one. How to read C well enough to know what this actually does. Like, where is the implementation of it? I don't. Or is this then? Like it does anything? Now this is like calling it. I think. Find. I'm gonna get defined anywhere. times 78. 9. We're doing floor division. Oh, you know, one thing we never did check on was the order of those things, right? Because um, these are unordered, right? And earlier the code just assumed which one was which. When we asked it to convert that, I mean, got them right, I guess. No. Okay, so count, then max, then DL, and then inside of those things, terms, those are DX, DY, DL. Ah, those are swapped. Count's supposed to come first. Oh, please let this be what makes it be the exact same. That would be awesome. Uh, Still not the exact same. Closer. Yeah, closer. Hold on, did we check the rest of the order there? DL, DX, DY. Stop going to the other. Number of items in terms. Yeah, okay. So 4. The maximum of the... Okay, yeah, I didn't see all these before. The maximum of the absolute value of the DX values. Thing, okay. The scaled dither value applied to the pixel at distance 1, 0. That means. And then that is DX, DY, DL. Those should be correct. Okay. And yeah, Atkinson is definitely 4-2, 6/8. Is there any chance that the order of operations is different because of the floor division? All right, well, it's closer than it was. That one, I think, still looks the same. All right, I will be back in a minute. That one's actually very close now. Still not quite the exact same. And sorry, I don't have the camera set up, so I can't show you very well, but it is very close now. I can basically only spot a few sort of single pixels that are out of place comparatively. Floyd Steinberg one was off a bit further, but this one is actually pretty darn close at this point. Is there a chance that make it any better? Only affect the Floyd Steinberg. Steinberg, I've been doing it again. It made a difference. How did I took those out? Comment that out earlier? Yeah, this one it's like the kind of general vibe is basically the same, but way more quickly I can find pixels that aren't the same. And I can find more of them. On the other one, it was kind of like one pixel here, one pixel there, one pixel over there, one pixel over there. This one is a bit more like I can see small chunks that are definitely different. But like overall, the effect is kind of the same, right? To my eye, they both look like black and white versions of Blinka. More or less what it's supposed to do, as far as I understand it. My only other real guess would be well, let's check if that did anything different. So this is the version with floats. And this one is floor division. Clicked on that to open. They're the same. Yeah, they're the same. Okay, so that makes no difference. Where the difference would come. This, which is doing floor division, and I assume not in the one. I would love to find where that's implemented in C. But I mean, this looks pretty much correct to me if I'm understanding. This looks like it's kind of just shifting 8 pixels one way and the other 8 pixels the other way. Let's check these. These are pretty much magic numbery. I like to think it could copy numbers correctly, but if bits per value, so it's else if bits per value is not. I don't have that as a high level thing. Where is this? Inside of fill row, actually. Here we go. So we have the else. Yeah, there we go. We have 8 shifted F8. They're capital, but they're the same. That's probably like a 565 thing. One thing that is interesting, this just says, so this says just pixel bitmap XY. So just get the current pixel from the bitmap. And this is right before if swap bytes, which is right before if swap bytes here. So presumably this is meant to be the same thing as this. But it's written very weird. I guess that's just how it goes though. Pixel data is a data comes from here. Data is an int16 pointer that came from data right and y. I don't understand the way it's accessing it enough to know if that's correct, but I'm kind of willing to say that I take its word for it, but I am curious. Let's see if it can you please explain to me if these if this line from the Python version it's mad now. Oh, I tabbed. Did I tab? I tabbed. Okay. Explain to me if this line from the Python version and this line from the C version are doing the same thing. So can you might be too hard. Not doing exactly the same. Online simply accessing a pixel. Dereference a pointer to get the value at a memory address. Pixel data increments the pointer to point to the next memory address. It's the current value and then advances the pointer. The C code pixel data. Okay, so I was wondering if it was going to go back and figure out the line 2 before that actually kind of factors in on the C code, and it did. So in C code, pixel data is a pointer that was previously set to point at the start of a row of pixel data. Start of a row of pixel data. Interesting. Finds the memory address at the start of row Y using that. Casts it to uint16 pointer. Then in the loop, it reads each pixel sequentially. Yeah, okay. Yeah, no, I don't think we need it to be the same, really. Okay. I mean, that's kind of more or less what I was imagining, but that's good to see it written out a bit more. It's essentially like you have a big list of. It is weird that it says starting at a row. So right. Oh, because we're in fill row, which is why. Fair enough. Okay. Yeah, I will say this. I mean, this is weird that swap gets passed and then not used. I guess. I mean, the logic should really be the same if we were to say swap. I believe this should work the same. Unfortunately, I don't know. We're actually exercising. same to me. Pass swap into this. Swap comes from. Okay, well, I guess the color space is where the swap comes from. What if we did BGR? Like, I mean, it doesn't seem to be changing anything. Strike me as on the portal did change a little bit. PC. So they're not the exact same for sure, but they're color space comes in. Oh. And even if they're not wrong, it's the wrong way to access them. We should be doing this, I think. Don't, maybe that's correct anyway, but I think we should be using these constant. Probably about time to get rid of that one. 565 swap. And BGR. BGR though. 565. I'm not sure that's working right. I think that changing those ought to probably change the outcome, the output picture. Doesn't seem like it is. Might be. Oh shoot. So we actually have this problem now. So we have, so if that wasn't working, now that we're not using those anymore, we have this problem. So these would actually need to be those. Yes, or else we could just. Nope, still the same. Swap is 2. Oh, that's different now. Hey, there we go. That's actually closer to the CircuitPython one. Honestly, that's pretty close. It's like it's still not exact. Especially this bottom right corner is a bit different. Like this sort, there's almost like this horizontal line here, which pretty much is on the last row only. CircuitPython one, which is interesting. Pretty close though, actually. What does BGR do? We do no swapped. Okay, that looks a lot closer to the original. I think actually we did move it in the right direction there. I think we probably were not, the way that was checking against strings, I think might not have actually worked for the way we're passing the constants. And now it's a bit better. Still not the exact same, but a bit better. Yeah, because that looks pretty close to the CircuitPython one when BGR 565 is passed in. The swapped one now looks a lot closer. That one looks a lot closer. Whereas before there was basically no difference. What was originally here? RGB 565. That's the default one. Curiosity, what if we do that? Guess we did. Yeah, we totally did. Is that different? I think that is actually just a tad different. I mean, truthfully, Blinka having purple, like mostly pinks and purples, actually probably makes it to where BGR and RGB is like not mattering a lot at all. Honestly, the pink here maybe, and obviously the teal is going to be changing, but because there's so much pink and purple, swapping red and blue is probably not actually having that big of an effect. Okay. I think that I am willing to call that good enough. Okay, so we have destination bitmap, source bitmap, color space, algorithm. So that matches. And we have a default algorithm of Atkinson. Which is specified up here. Nice, maybe. So that matches. Ooh, excuse me. And we don't have any defaults for any of the rest of the arguments. You have to provide all the rest of them. Okay, so I think that matches. Okay. So now, I believe that that is actually the last function. I believe everything else might be already done. At least done as in implemented at all. The thing that is left at this point is default behaviors, default values and behaviors. So like read into, for instance, let's take a look through it. So it takes a destination bitmap. It calls it bitmap, I guess, but it's destination. We know that. It takes a file. Yeah, this one reads a binary file. It's kind of interesting. I didn't know what this did either, but I kind of tinkered around to figure it out. It takes a file. It takes per pixel. It takes element size. That one defaults to 1. It takes reverse pixels in element. That one defaults to false. We have those values defaulting, but we might need to go and modify the code to be like, if it's the default value, then behave this way. I think some of them are going to need that. Like there's especially places where if you don't pass like a width or something, then it uses the width of the bitmap. I think those are not implemented in Python yet. Reverse is false. Okay. Bits per pixel. You have to provide that. Element size is the first one that has a default. Number of bytes per element. I don't even really know what that means. Element. I'm not sure where the element noun came from. This says reads from a binary file into a bitmap. The file must be positioned so that it consists of bitmap height, rows of pixel data, where each row is the smallest multiple of element size bytes that can hold bitmap with pixels. Boy, that is a lot of things. Okay. The file must be positioned so that it contains height, rows of data. Okay. Height, rows of data. That part's easy. Each row is the smallest multiple of element size bytes that can hold with pixels. Ah. Okay, I think I get it. Basically, the number of bytes that it takes to store a pixel differs based on the color space. This is saying pixel data is going to contain rows where every row contains the smallest amount of bytes that it can to be able to hold all the pixels it needs. Potentially, maybe that means there's filler at the end, but I'm not positive. Like in PNG in the data structure, there's parts where there's like filler data. Maybe that means, because it could be the smallest multiple of element size. If element size is not an even multiple of width, yeah, if element size is not an even multiple of width, then there's gonna have to be some padding data, I think, at the end of the last byte, basically. The bytes in an element can be optionally swapped, and the pixels in the element can be reversed. Also, the row loading directions can be reversed, which may be required. That should probably be required for loading certain bitmap files. This function doesn't parse image headers, but it's useful to speed up loading uncompressed formats like PCF. Okay. There's really nothing in this that's like default width. So I'm going to kind of take the cop-out road of assuming that that works correctly. They'll proven otherwise. Because that's another one where like I had never actually used that. I didn't even know what it did. But I tested it, figured it out on the microcontroller, and then implemented it here. And it now does the same thing. We could run the test for it, maybe. I made like a pretty colorful test for that. Into this. Oh. Oh, I think it's messed up actually because of the colors. Want. Well, I also ended up doing. Oh, okay. That's what we're looking for. This one, though, we have our X1 and our Y1. So these are where I think there's going to be some more work to do. So insert pixels from data into the rectangle of width times width by height pixels with the upper left corner at XY. The values from data are taken modulo the number of colors. If X1 or Y1 are not specified, they're taken as 0. Okay, so we have that based on the default value, so that's fine. But then here, if X2 or Y2 are not specified or are given as none, they are taken as the width and height of the image. I don't know that we have that functionality. Actually, we do. It's right there. Fair enough. Okay. Coordinates affected are this. The data must contain at least enough elements. Takes place by rows. I don't think we care about the rest of that. That seems fine. I mean, this is awkward. This could be like optional int, right? I think that'd be nice. Skip index. Is that actually getting used? Yeah, that's there. I mean, this one's pretty easy, right? Once you understand the data structure, it's kind of like just loop through it and copy from one to the other. The X2 and the Y2 was the bit I wasn't sure if that was implemented. I think, I mean, I think there's going to be some of those that are not implemented, but we'll see. The polygon, I don't know that this will have anything, but let's check. So draw it, connecting the points, destination bitmap, X's, Y's, value, and then close. Defaults to true. We actually have this as optional here, which is a bit weird. I don't think that should be. I think it should just be bool, right? It should just be always true or false. It defaults to true. That's fine. Nothing else has a default readable buffer. Yeah, it's pretty much actually just a list in this case. Okay. I think that's good. Draw a circle, draw a line. Well, let's go. I've been going in this order, actually. So draw a line is up next. Draw a line, draws a line, specified x1, y1, x2, y2. Yeah, none of those have any defaults, so I think we should be fine there. None of these have any weird types. Boundary fill. Oh, maybe that one's not done, actually. One might not be done. That one's not done. Yeah. Okay, boundary fill is perhaps the last one to do. Fill region. Draws the color into the rectangle bounded by x1, y2, exclusive. And again, there are no defaults here, so I think this one should be fine. Rolled me far away. Oh, I see what happened. I was trying to click those dots, but I got the scroll bar. Yeah, okay. Be fine. Alpha blend. All right, so boundary fill I have to do. Somewhere I had, like, I actually wrote boundary fill originally in the core, and somewhere I have a Python implementation because I wrote the Python one first to wrap my head around the algorithm. One thing we probably need still is doc strings on more of these. I think very many of them have doc strings. One has no X and Y stuff. It's got a lot of nuns. This should be an optional int if it's going to be none, right? End mode. This actually defaults factor 1 to 0.5. We have not done, so let's do that. But factor 2 has no default. So actually these are, well, factor 2 at least is optional. I don't know why that's red. Red. On default. Oh. Guess we need to make this none. Trying to put in as well. Okay, it's fine. Roto zoom. This one, I think there could be, whoops, there could be some more of the width thing going on. So let's see what we have here. Insert source bitmap region into desmap destination with rotation angle, scale clipping on both. Okay. Destination bitmap. Could type this up, I guess. OX, horizontal pixel location in the destination bitmap. Where it's placed defaults to none, which causes it to use the horizontal midway point of the destination bitmap. I think there's a very slim chance that that is actually. Yeah. In fact, this would probably just raise an exception, right? Because it doesn't have a default value, and then it's just using it in an equation right here, and nothing like sets a value on it. So we should say this is actually an optional int, and its default is none. Same thing for this. And then if those are none, if OX is none, OX equals horizontal pixel location in the destination where the source point is placed defaults to none, which causes it to use horizontal midway of the destination. That would be destination bitmap width over 2. Oi. Yeah, okay. Destination clip. So this says tuple int. First corner of the rectangular destination clipping region that constrains the region of writing into the destination bitmap. Second corner of the rectangular destination clipping the region that constrains the region of writing into the destination bitmap. I don't know if those, but they should be none, I guess, by default. Yeah, I mean, they come after this, which I think means they will be optional, right? Keyword arguments, they should default to none, I think. Although, I don't know what would happen if you said... Can you use the spreading thing on none like that? Cannot. Okay. Did I test clips? I know I tested roto zoom generally. Roto zoom. Ah, I had a clip. Okay, so I think we need to make that do something by default. What should it? It's weird that it doesn't say. I would assume by default it's the entire destination size, right? Fairly safe. Like shared binding. Clip region. So clip does default to none. There's where that gets set to the midway point. Looks like we're going to want to do the same thing for PX, PY, but those come after dest clip, so we'll get to those in a minute. Validate the clipping regions for the destination bitmap. So clip X, clip Y. That's actually just creating them. That's not validating anything. This one maybe. Destination. So this is getting the object of clip 0, and then it's getting the address of these integer int16t objects. That's kind of interesting. Then it's getting clip 1, so it's getting the same thing basically. So we get the object, clip 1, clip 0, then it's also getting the addresses to those integers. And then inside of that, it's doing what? Calling extract tuple. Extract the clip XY point from the two clip tuples. Rearrange the values such that clip 0 is... Okay, constrain the clip points. So do we have validate at all in the Python implementation, or... Okay. Okay, and then this must be default values, right? So that takes a tuple object, pointer to x, y, and then default values also. Okay. If the tuple is none, then x is the default and y is the default. Otherwise, unpack the tuple and get the values out of it. And then that is going default to 0, 0, and that is going default to bitmap width, bitmap height. So in my head, truthfully, source clips default should just be the tuple 0, 0 instead of none. But I don't, in CircuitPython, I don't know that it can default to a tuple like that. So we'll try to mimic this more closely. So we're going to say those default to 0, and then if source clip is none, we're going to make it 0, 0. And if that is none, we are going to make that the destination bitmap width. I'd have to test that to know for sure. I'll go with -1 for now. I'm not sure if that should be the full width or... I mean, well, in the C code, it's the full width. We want the full width, probably, actually. There's probably like a 4 range, maybe, that's going to cut off the last one or something. Okay, so I think that should cover those. Oh, was I just been doing the wrong ones the entire time? These are source clip, and it should have been dest clip. Not the entire time. Yeah, I'm sure we're gonna here. So that is dest, yeah. All right, so OX, OY, and then dest clip, dest Y, and then PX, PY, and those do the midway point of the source. So this logic is basically going to be the same. I'm going to keep them in the order of the arguments. No, it doesn't really matter. And then we do have source clip, source clip 0 and source clip 1. Validate region the same way. Well, validate clip region handles both. I guess we should probably still have logic that does this part. We don't have that in the Python one yet. But this is totally gonna do. Hey, wait a minute. This only gets past one bitmap. So actually it gets past. Oh no, I'm being silly. Okay, yeah. This is the destination one. It takes X and Y for both clip 0 and clip 1. And then it takes, of course, the objects, and then it also takes the destination, the bitmap. Then that one is source. So it is going to be source width and source height based on the defaults. Yeah, so that logic is the same. I'm not going to bother putting that into its own function. I mean, I guess by the time we have, if we do the less than thing, it would make sense as its own function. It's not really validating, right? Because if they're validating out of range or something? I mean, it doesn't raise an exception. It's not really validating either. It's just like constraining. It's saying like if it's invalid, then it gets changed to something that makes it valid. But it's not like telling you it's invalid necessarily, as far as I can understand it. Okay, do the last couple, and then I think I will head out for now. So angle is in radians. It defaults to none. It's treated as 0, 0, or no rotation. So I mean, it should just default to 0. Angle none. If angle none. So that could just default to 0 here, and it would sense in my head, but that's rolling scaling fact. Defaults to none, which gets treated as 1.0, or the same as the original source size. Equals none. If scale is oh, skip index, set to none to copy all pixels. Then if all of these are none, they should also Yeah, option. Well. All right. I think I'm gonna call it a day for now. Thank you to everyone for hanging out. You all have a good rest of your day and a good weekend and all that. I am back for deep dive next week. Is this really not scrolled? Scrolled past the bottom. I didn't realize we were our chat's like a little bit off the bottom of the screen there. Oh, now it's probably really better. Oh, well, this might be delayed. Doesn't matter at this point because we've been. I think it's just delayed. I'm finally catching up now. Anyway, yeah, there it goes. All right. So yeah, I'll be back. Deep dive next week is my first deep dive, and then I'll be doing deep dives for a while till Scott gets back. Several months at least, I think. At least 2 or 3 months, perhaps longer, probably longer. At some point, I'm probably gonna switch up my weekend stream. I'll probably trade out the 10 a.m. Saturday time slot for something else, but I don't know exactly what yet. And I'm not quite ready to do it. So next Saturday, I believe, should be normal time, even though there is a deep dive on Friday as well. But yeah, keep an eye out if you are interested in catching weekend streams. At some point, I'm probably going to be moving it either to Sunday or later in the day on Saturday or something. I don't know for sure what. If anyone who's watching has any preferences on like when is the easiest time for you to watch on the weekends, let me know. But I think I want a little bit more time in between deep dive on Friday night and then my stream on the weekend. But I'm not decided yet, so next week I'll be normal. Deep dive on Friday night, 4 p.m. Central Time, 2 p.m. Pacific, 5 p.m. Eastern Friday night on the Adafruit channel, and then back here on my channel 10 a.m. on Saturday for next week. See you all later. Thank you for watching, and